soil mechanics and geotechnical engineering. First one is size of boulders 300 mm, size of gravel 4.75 to 80 mm, size of sand 0.075 to 4.75 mm, size of silt 0.75 to 0.002 mm, and size of clay is less than 0.002 mm or 2 micron. Next is process of soil: weathering, transportation, deposition and upheaval. Next one, types of soil. Residual soil is formed by weathering process, that is black cotton soil, and black and cotton soil formed by basalt or trap rocks. Next one, transported soil, location changes. Transported soil means soil formed due to location changes. Next one, water transported, that is also known as alluvial deposit, for example silt. Next one, wind transported and also known as alluvial deposit, for example loess and sand dunes. Loess are low density soil. Next one, glacier transported, also known as glacial drifts, and for example eskers and cames. Next one, gravity transported, also known as alluvial soils, for example talus soil. And permeability of loess is large in vertical direction. Next one, cohesionless soils. Coarse grained soil are cohesionless, for example sand and gravel. Fine grained soils are cohesive soils like silt and clay. And organic soil, for example peat. And what is soil profile? Soil profile is the vertical section through the ground along the line of exploration, that is having different layers. Soil deposits in India. First one, marine deposits, that is formed in Rann of Kutch, that is in Gujarat. And for example marine clay, sometimes it contains organic matters. Next one, black cotton soil. Black cotton soils have high shrinkage, swelling and volumetric changes. Next one, laterites. Laterites are decomposition of basalt and contain iron oxide, which is responsible for the red color in laterites. Next one, alluvial soils, that is silt, clay, and it is also known as water deposit. Next one, desert soil. Desert soils are formed mainly in Rajasthan, also known as dune sand. Lake deposit, also known as lacustrine deposit. And these are short terms. Clay is more cohesive than silt. Very important. Bulking occurs in sand. Next one, cohesion of soil decreases with increase in particle size. Dune sand is wind deposit. Next one, loess is alluvial soil, that is wind deposit. And soil work organization, there are mainly two types of organizations. First one, central soil salinity research. Next, central soil and materials. Next one is Soil is formed. Soil word is derived from the word solium. That is Greek word solium. Soil mechanics. Father of soil mechanics, Carl Terzaghi. And clay mineral montromoritonite present in black cotton soil. Kaolinite is clay mineral. Drift is glaciated water. And porosity is also known as percentage voids. Next one, physical properties of soil. Three-phase diagram and two-phase diagram. In three-phase diagram, soil consists of water, air and soil. In two-phase system, soil consists only air plus soil, that is known as dry soil, and fully saturated, that is water plus soil. Next one, important terms in soil. First one is void ratio, that is denoted by small e. It is equal to volume of voids to the volume of soil, and is equal to n upon 1 minus n, where n is equal to porosity, and porosity equal to volume of voids to the total volume, and that is also equal to void ratio upon 1 plus void ratio. Next one, degree of saturation denoted by S, that is equal to volume of water upon volume of voids, and void ratio, degree of saturation and water content specific gravity relation, ES equal to WG. Next one, water content denoted by W, that is equal to weight of water upon weight of solid. Next one, dry unit weight, that is gamma D, that is equal to G gamma W upon 1 plus E, where G equal to 2.7. Mainly G is assumed as 2.7 for calculation, and gamma W, that is equal to 1 gram per cc, and dry unit weight is also equal to unit weight upon 1 plus moisture content, and that is unit weight equal to weight upon volume. Next one, unit weight is also equal to G plus SE upon 1 plus E into gamma W, that is G equal to specific gravity plus degree of saturation into void ratio upon 1 plus void ratio into unit weight of water. For saturation equal to 1, gamma saturated is equal to G plus E upon 1 plus E into gamma W. Next one, mass specific gravity, also known as apparent specific gravity, and phase diagram, also called block diagram. Next one is consolidation. Consolidation is the compression of a saturated soil due to expulsion of water from the voids under long-term static load. These are three types of consolidation. First one initial, second primary, and third one is secondary. In initial consolidation, volume decreases and compression of air. And primary consolidation is reduction of volume due to water expulsion. And secondary consolidation is additional reduction even after primary consolidation. Next one, degree of consolidation, that is denoted by U, and in percentage, that is equal to U equal to S upon SF into 100, where S equal to settlement at time t and SF is settlement, final settlement. Next one, important terms in soil mechanics. First one, clay minerals. There are mainly three types of clay minerals. First one, kaolinite, that is also known as China clay, and montmorillonite, that is in black cotton soil, and third one is elite, that present in shale. And clay mineral thickness measured in angstrom, that is 1 angstrom is equal to 10 raised to power minus 7 mm, and 1 micron is equal to 0.001 mm. Next one, sieve analysis. Sieve analysis according to IS 1498-1970. Material used in sieve, that is spun brass and phosphor bronze. Dia of sieve is ranges between 15 to 20 centimeter, and for coarse grained soil, coarse sieve is used. And following are the dia or classification of sieve. For coarse sieve, sets are 80 mm, 40 mm, 20 mm, 10 mm and 4.75 mm. For fine sieve, that is 2 mm, 1 mm, 600 micron, that is 0.6, to 425 micron, that is 0.4 to 5. Next one, 2.12 micron. Next, sorry, 212 micron, 150 micron and 75 micron. Next one is coefficient of uniformity, that is denoted by CU, and that is equal to D60 upon D10, where D60 equal to particle size of 60% of soil is finer, and D10 is particles size 10% of soil is finer. For well graded gravel, coefficient of uniformity is equal to or more than 4, and for well graded sand, coefficient of uniformity is equal to or more than 6. Next one is methods of sedimentation analysis of soil, that is number 1, by pit method, and second one is hydrometer method. In hydrometer method, soil passing through 75 micron is taken, and this test is done at 25 degrees Celsius temperature. Next one is activity of soil. Activity of soil is equal to plasticity index upon clay fraction. For less than 0.75 activity, soil is inactive, and for 0.75 to 1.25 activity is normal. And one more important term, relative density, most important topic. Relative density is equal to void ratio maximum, E maximum minus E, that is void ratio, upon E maximum minus E minimum. Very important to remember. And next one is plasticity index. Plasticity index equal to liquid limit minus plastic limit, and liquid limit determined by Casegrande's liquid limit device, and cone penetration method. And that is IP, Plasticity Index. Plasticity Index is 0% for sand, and 0 to 7 for silt, and 7 to 17 for silty clay, and more than 17 for clay. Next one is toughness index, that is denoted by IT, is equal to IP, that is plasticity index upon flow index. As per 1478 to 1970, symbols used for different soils are: G stands for gravel, S for sand, M stands for silt, C for clay, O for organic soil, and P is poorly graded, H is high compressibility, I is intermediate compressibility, L is low compressibility, and PT stands for peat, that is organic soil. Plasticity chart drawn between the plasticity index and liquid limit. Plasticity chart is the plasticity index and liquid limit. Next one, group index parameter. Group index parameter used in HRB classifications. And next one, dry strength test of soil is done with the help of taking the sample between fingers. Dry strength test between fingers. Next one is flow of water through soil, that is permeability. Permeability is the property of soil which permits the flow of water through the soil, and K is the coefficient of permeability. Coefficient of permeability, units of coefficient of permeability is centimeter per second. Next one, hydraulic gradient. Hydraulic gradient is denoted by I, and that is equal to head loss upon unit length, that is H upon L, and LH is the head loss, that is H1 minus H2. Next one, Dorsey law. Dorsey law states that velocity of flow is directly proportional to hydraulic gradient, and V equal to K into I, where K is equal to permeability coefficient. And discharge, in terms of Dorsey law, discharge equal to K into I into A, where is Q equal to discharge, K equal to coefficient of permeability, I stands for hydraulic gradient, and A is equal to area. Next one, seepage velocity. Seepage velocity is denoted by Vs, and Vs is equal to Q upon AV, where Q equal to discharge and AV is area of voids. Next one is Vs, seepage velocity. Seepage velocity is also equal to 1 plus E upon E into V. It is very important. And for bonus, coefficient of permeability is directly proportional to square of void ratio. Next one is measurement of permeability in labs. There are mainly two methods of permeability. First one, constant head. Second one, falling head. Constant head method is used for coarse grained like gravel and sand, and falling head is used for fine grained, that is sand, silt and clay. Next one is in constant head test, coefficient of permeability is equal to discharge into length upon area into head loss into time, that is QL upon AST. Second one is falling head test. In falling head test, K is equal to 2.303 AL upon AT into log 10 H1 upon S2, where T equal to time, A equal to area, small a is equal to area for the section. And next one is measurement of permeability in field. This is the lab for labs, and this is in field. Sorry guys. Permeability in field. There are two type of tests for in field: pumping out test and pumping in test. And permeability tests in field are more accurate and generally used. Next one, aquifer. Aquifer are underground water reservoir in porous soil deposit. From this, water can be pumped out. Next one is aquiclude. Aquiclude is impervious soil deposit containing water, and water cannot pump out. Next one, confined aquifer. When aquifer is between two aquiclude, that is known as confined aquifer. And aquifer is unconfined when the top of the aquifer is aquiclude, means aquiclude is on top of aquifer. And next one is effective stress in soil. That is, first one is total stress denoted by sigma equal to P upon A, that is force upon area or load upon area. And second one is effective stress denoted by sigma bar equal to sigma minus mu, that is sigma bar is effective stress, sigma is total stress, and mu is neutral stress. And neutral stress is equal to gamma W into H, that is unit weight of water into height of water. Next one is deformation of soil. Deformation of soil is change in shape or volume of soil mass by vertical or lateral movement under the effect of load, that is known as deformation of soil. Next one, swelling. Swelling is increase in volume of soil mass when water is added to it. This is mainly occur in black cotton soil, and that is contain montmorillonite mineral. Creep means to move slowly. Creep is the slow and gradual lateral advancement of soil, mainly occurs in retaining walls. Next one, heaving. Heaving is upward movement of soil when, for example, when piles are driven in saturated fine-grained soil, heaving is occur. Next one, plastic flow. Plastic flow is continuous soil deformation in highly plastic soils and having constant shearing stress. Next one is compression index. Compression index is the slope of the linear portion of the void ratio versus log sigma bar plot. That is void ratio and effective stress slope. Next one is settlement. Settlement is vertical downward displacement due to decrease in the volume of soil. Thank you guys. Please like and subscribe.